Hi friends, so today we are going to be doing section 2.8, which is solving inequalities in one variable. Go ahead, take out your notebooks and we're going to take notes with this. We're going to use this new process called a sign chart. So this is something a little bit new. You've solved inequalities before, but we're going to talk about a different way we can do this. So we're going to let f of x equal x plus 3 times x squared plus 1 times x minus 4 quantity squared. I want to determine the real number values of x that cause f of x to be 0, positive, and a negative. So they're asking for three things. I know everywhere that it's 0, everywhere that it's positive, and everywhere that it's negative. The way we're going to answer this is by using this thing called a sign chart. So we're going to first start with our zeros. To find our zeros, since it's in factored form, I'm just going to set each piece equals to 0 and solve. This first piece, I get x equals negative 3. This next piece, oops, there we go, I get plus or minus I, but I want the real number zeros. That's not a real number, so I don't want that. And then this last one, I get 4. However, notice that that was raised to the exponent of 2, so I'm going to add a multiplicity 2 at the end of that. Then what I'm going to do with those is I'm going to make this thing called a sign chart. It's going to kind of look like a number line. On this number line, I only want you to label the zeros. So I need to see negative 3 and positive 4. So I'm just going to say, here's where negative 3 would be. Here's where positive 4. And I'm going to literally label that this is a 0. And this one is a 0, but I'm going to put multiplicity 2 after it. Okay. Then what I want to do to finish this, I'm going to look at the signs. So what I mean by look at the signs, pick a number somewhere over here, meaning pick a number that is less than negative 3. So let's say negative 4. And I'm going to go back to my original function. I'm going to think, if I put a negative 4 in this first piece, negative 4 plus 3 is negative 1, I get a negative answer back. So I'm going to put a negative sign to show that in that first piece I get a negative. Then I'm going to put a negative 4 in this piece. Negative 4 squared would be positive 16. 16 plus 1 is positive 17. So in that second piece, I get a positive, so I put a plus sign. And then finally, I'm going to put negative 4 in this last piece. There's two ways you can write it, but negative 4 minus 4 would be negative 8. But remember, I have two of them. So I'm going to just write that I've got those two signs. So once I've got that, then what I'm going to do is I just need to figure out if I were to take a negative times a positive. What I'm doing right now is I'm looking at these signs right here. If I were to take a negative times a positive, that'd be negative. Times another negative would turn it positive. Times one more negative would turn it negative. That tells me that every number I pick that is less than negative 3 is going to be a negative value. Then I'm going to repeat that process, and I'm going to pick a number somewhere between negative 3 and positive 4. I'm going to pick 0. So if I put 0 in that first piece, 0 plus 3 is going to be 3. That's the positive number. If I put 0 in that second piece, 0 squared plus 1 is going to be 1. That's a positive number. And 0 in that third piece, 0 minus 4 is a negative 4, but I have two of them. So a positive times a positive times a negative will end up being a positive number. And then finally, I need to pick a number to the right of 4. So to the right of 4, that'd be like 5. So 5 in that first piece. 5 plus 3 is 8. That's positive. 5 squared, 25, plus 1, positive. 5 minus 4 is 1, but there's two of them. Positive times a positive times a positive times a positive is a positive. So for the ones that just ask you to find all the real number values where it could be 0, positive, or negative, what I actually want for your final answer is this sign chart right here. Because I should be able to look at that and find all the places where it's negative, all the places where it's positive, and all the places that it's 0. What that sign chart is actually telling me, if I had to, which I'm not going to right now, but if I had to transfer that to a graph, I would know that there's a 0 at negative 3. There's a 0 at positive 4. the graph starts out negative, it goes up here in the positive, comes to 0, and then it goes back into the positive, which should make sense with our knowledge of multiplicities. That's an even multiplicity, so notice right here, it just touched the x-axis, it didn't cross. This is an odd multiplicity, so right there it crossed through the rx axis. So all these things are kind of being tied together if I had to make a graph. Okay, then I've got this. 2x cubed minus 7x squared minus 10x plus 24. This one is not in factored form. I can't factor it to get it into factored form. So what I am going to do is I am going to try and graph this. So I need to bring up my graphing calculator. There it is. And on my graphing calculator, I'm going to go to my y equals, and I'm going to type in 2x to the third minus 7x squared minus 10x plus 24. I'm going to look at that graph. There's that graph. Now, it is an inequality. I get a graph that kind of looks like that. What I'm going to do is I'm going to find the 0. So I'm going to hit second, calculate 0, option 2. I'm going to go to the left of this first one. Go to the right, hit enter, and it tells me my first 0 is at about negative 3.88. And then I'm going to repeat that process. Second, calculate 0. As I'm doing this, I'm watching my y values to see if I'm getting closer. There's a positive y value, there's a negative y value, which tells me there must be a 0 in between. That's about 1.12, I'm going to say. And then finally, I'm going to find my last 0. And that's about 2.77. Okay, since this is an inequality, it's saying when is this graph greater than 0? It is greater than 0 at this piece and that piece, because 0 would be right here. So I need to find a way to say that it's greater than 0 on those two pieces. Well, that first piece starts at that negative 3.88 and it ends at that 1.12. I do want to look here to see that it's just a greater than, not greater than, or equal to. So that tells me I want to use a parenthesis and say starting at 3.88 until I get to 1.12. As well as that second piece starts at 2.77 and it goes up, but more specifically, it goes to the right forever. So those would be our two answers. Since it's both of them, we can say it's the union of those two sets. You do not need to write that, but mathematically, that is what we're talking about. Those two sets would be our answers. Okay, I'm going to skip, well, I'm not going to skip this one. This one really quickly is very similar to that last one, but here's my only advice. If I had to solve this one graphically, I would do it just like that last one that we did, but I personally like to have it set equal to 0. So I'd have x cubed minus 6x squared plus 8x minus 2 is greater than or equal to 0. And now that I've got that, then I can go back to here and say, okay, I need x cubed minus 6x. Oh, I just realized something, friends. I'm going to 6x squared plus 8x minus 2, x cubed minus 6x squared plus 8x minus 2. Perfect. So I've got that right there. I'm going to graph this. I get that graph. And then I'm going to do second, calculate 0. I just realized as I started this one, that last one I typed in wrong. So we will fix that. But on my first 0, it looks like is at 0.32. My next zero is at 1.46. So I can calculate zero, and my last zero is at 4.21. This one is now saying when is it less than or equal to zero. Here's zero. Less than or equal to zero would be this piece and this piece. That first piece is starting as far left as I can go, so negative infinity, and it's going all the way up to that 0.32. In this case, I want to include it because it says less than or equal to. And then my second piece would be from 1.46 to 4.21, and there would be our two graphs, or two intervals. I have to backtrack to this because I just realized that when I typed that into my calculator, I did not type it in correctly. So let's just fix these numbers. 2x cubed minus 7x squared minus 10x plus 24. We're still going to have the same general cubic graph, but our zeros are going to become drastically different. So I'm going to do second calculate zero for this one. It should have been at -2. And the next one should have been at 1.5. And my last one should have been at 4. I apologize for that, friends. Here's the good news. It is still saying when is it greater than or equal to 0. It was still the same general shape because it was a positive cubic. So what I have to fix is just where my zeros were and then fix my answer. So it should be -2 to 1.5 and 4 on to positive infinity. It should not be this. I apologize that I originally explained that wrong. Okay. This one, do not write down. So I've got example 4 here, but it just says solve graphically. I just want to point out the sign of your inequality absolutely matters. So that sign right there, I know that this graph can factor to be an x plus 3 and x plus 3. Once again, just watch this. You don't have to necessarily do this one. So really I have that quantity squared, which tells me that I have a 0 at -3 multiplicity of 2. Tells me that my graph looks like this. The reason why I wanted to point this one out, it says when is it greater than 0? Be careful with that inequality. Since this one does not include 0, for this you could say all real numbers except x cannot equal -3. That's when it is greater than 0. If I would have changed this just simply to say this, when is it greater than or equal to 0? Well, now I can include that 0, so now I would say all real numbers. If I would have changed it to be when is it less than 0, well, if I look, that graph is never less than 0. So you can say no solution. And then finally, if I would have had it say less than or equal to 0, well, it's never less than, but it is equal to 0, and that one would just be simply at x equals -3. So please be very careful when you're looking at the inequality signs. Sometimes it won't affect it, but a lot of times it will. So the less than versus less than or equal to, or greater than versus greater than or equal to. Okay, then these last few. We're going to make a sign chart to determine when f of x will be 0, undefined, positive, and negative. So now we're getting a little bit more complicated. It's not just a polynomial function. We are going to start by finding our zeros and undefined, just like in example 1 when we found our zeros. I'm going to set the top equal to 0. If the top is equal to 0, that means the top of a fraction is 0, and 0 divided by anything is 0. This will give me my zeros. So I'm going to subtract 1 from both sides. divide by 2, and I get x equals 1/2, negative 1/2, excuse me. That is the only 0 for this one. The undefined are going to be when my denominator equals 0. So when I solve that, I get x equals -3, and x equals +1. So then I'm going to make my sign chart, and I need to see all of my zeros and all of my undefined. So I need a -3 on here. That was undefined. I need a -1/2. That was a 0. And I need a +1, and that is an undefined. Then I'm going to just once again look at the signs. So my first thing I want to do is pick a number less than -3, so like -4. I'm going to put that into the top of this fraction. 2 times -4 would be -8, plus 1 would be -7. It's a negative number. Then I put the fraction bar. If I put -4 in the denominator, -4 plus 3 is a -1. -4 minus 1 would be -5. In my denominator, I know a negative times a negative would be positive, and overall a negative divided by a positive would be negative. So any number that I pick less than -3 is going to end up being a negative number. Between -3 and -1/2, I could pick like -2. So now I substitute that in. -2 times 2 would be -4, plus 1 would be -3. That's a negative. -2 plus 3 would be a positive. -2 minus 1 would be a negative. So that's going to end up being a negative over a negative, which is positive. Then I need a number between -1/2 and 1. I'm going to pick 0. 2 times 0 is 0, plus 1 would be a +1. 0 plus 3 is 3, and 0 minus 1 is -1. A positive divided by a positive and then multiplied by a negative is going to be negative. And then finally a number greater than 1. So greater than 1 would be like 2. 2 times 2 is 4. 4 plus 1 is 5. 2 plus 3 is 5. 2 minus 1 is 1. Positive divided by a positive times a positive would be a positive number. So if they are only asking for making a sign chart, showing me where I have all these values, your sign chart can be your final answer. Then I'm going to come across ones like this and ones like this, where it says actually solve. The difference between these is now I actually have an inequality in that one, and I have an inequality in this one. In order to solve this one, what I want you to do is I actually want you to combine those two fractions together, get a common denominator. Once you have a common denominator, then we can hopefully make a sign chart. So my common denominator is going to have to be for this one, multiply the top and the bottom by an x minus 1, multiply the top and the bottom of this one by an x plus 3. My goal is to somewhat keep this in factored form because sign charts are easiest if we're in factored form. So this denominator I am not going to multiply out. The numerator I am, so that I can get it to combine like terms. So I'm going to get a 5x minus 5 plus a 3x plus 9, which would really be 5x plus 3x, that would be 8x. -5 plus 9 would be 4. And I could at this point make a sign chart, but I noticed one other thing. In that numerator, I could factor a 4 out. That'd be 2x plus 1 over x minus 1, x plus 3. The reason why I wanted to do that is because I believe if I look at that last problem we just did, there's a 2x plus 1 on top, just like there's a 2x plus 1 on top here, and an x minus 1 and an x plus 3 in the bottom, and an x minus 1, x plus 3 in the bottom. The only thing difference between this example and that last example is that I'm multiplying by a +4. Well, if I go back here and say, well, I actually also need to multiply by a +4, by a +4, by a +4, by a +4, that's not going to change it. A negative times that +4 is still a negative. A positive times that +4 is still positive. A negative times that +4 is still negative, and a positive times that +4 is still positive, meaning to solve this problem, I can use the sign chart I've already created. And here's how I use a sign chart to answer it. It is saying when is it less than 0, not less than or equal to, just when is it less than 0. Less than 0 means that I have a negative number because negative values are less than 0. It is less than 0 here, and it's less than 0 here. I have to be careful. I don't want to include the zeros because it just says less than, and I never want to include undefined. So when I write it, I'm going to say from negative infinity to negative 3, not including either. And from negative 1/2 to positive 1, not including either. So I want both of those. If you want to say the union between those two, that's perfect. But those would be my intervals where that rational function is less than 0. Okay, last one, I believe, and then you should be good for your notes. Make a sign chart for this one. So we're going to solve this one. This one, there's no fractions. If there's no fractions, that means that right away off the top of my head, there's no undefined. There could be an undefined because of that square root. In fact, there will be. But for right now, I'm going to find my zeros. My zeros are if I set each piece equal to 0. So this one, I get at 3. Here I can square both sides. So I have zeros at negative 1 and positive 3. Side note, when I write my final answer, I want it to be greater than or equal to 0. So I want to make sure that when I write my final answer, I include those zeros. Okay. Then I'm going to do my sign chart. So a number less than negative 1 would be like negative 2. Negative 2 minus 3 would be negative 5. Negative 2 plus 1 is negative 1. I have the square root of a negative, which I cannot do and get real numbers. So what I have to say is there's an error there, which means that this is undefined. Any number I pick that is less than negative 1 is going to give me an error in that square root. I don't want it. Then I'm going to pick between negative 1 and 3, so like 0. 0 minus 3 is negative 3. 0 plus 1 is 1, and the square root is positive. I know it's a positive because even though we normally say, well, with square roots you have to write plus or minus, what is listed here is no sign, meaning what is listed here is the positive square root of x plus 1. So back to my sign chart, a negative times a positive would be a negative. And then finally, a number bigger than 3 would be like 4. 4 minus 3 would be 1. 4 plus 1 is 5. Square root of 5, I might not know off the top of my head, but once again, it's the positive square root. And a positive times a positive is a positive. So I want to know all the places on that sign chart that are greater than or equal to 0. Well, it is greater than 0 right here, but it's also equal to 0 right there. So this piece is an interval because it's more than just one number. So I'm going to say from 3, as far right as I could go, and when x equals negative 1. Okay, that is it for notes today, friends. Sorry about that little mix-up before. Hopefully it didn't mess up your notes too much. Have a great day.